Hello and welcome to Learning AngularJS Testing by Pact Publishing. I'm Rudolph Ola, your presenter for this video course. I run the Learning AngularJS newsletter and have been a web developer for the last 5 years, working with Rails, Django, and Node.js. AngularJS is an amazing technology because it provides a framework with the basics included. It gives you everything you need to make good, responsive, high-quality web apps. In this series of screencasts, we will be learning how to fully test an AngularJS web app. The web app is a pizza store from which customers can order a pizza. We will learn how to unit test and end-to-end test this application. In the following videos of Section 1, we will begin with setting up the app with a single controller and the testing infrastructure for running unit and end-to-end tests. In Section 2, we will be creating controllers for our app and testing them with and without dependencies using mocks. We will also be conducting an end-to-end test of them. In Section 3, we will be testing directives. Directives are the HTML components that contain their own logic, which need to be fully tested using unit tests. Designing an end-to-end test for a directive is covered in this section. In Section 4, we use mock objects to test a service that relies on the resource module and uses a REST API. We hook the service up to a directive and to a controller and test those as well. You'll need your text editor and a web browser. So let's begin this journey together, and I hope to see you there.
Hello and welcome to the first section of this course, setting up AngularJS for unit testing and end-to-end testing. In this section, we'll cover setting up our environment and configuration for testing. Since we are practicing test-driven development, our goal in this video is to create a unit test and run it using a task and test runner. In this video, we will install Jasmine and create a unit test, install Karma and configure how we run unit tests, and install Grunt to run unit tests as soon as we modify our code. In test-driven development, before we write any code, we have to write a unit test to make sure that we write the correct functionality. To write unit tests, we need a test framework, a test runner, and a task runner. We can use Jasmine as our test framework, Karma as our test runner, and Grunt as our task runner. The reason we use Jasmine is because it has understandable and readable methods for testing. It makes unit tests almost read like a sentence. We're using Karma as our test runner because it will run unit tests in all web browsers that we want. It is the standard test runner used by many AngularJS projects. We use Grunt because of its easy-to-read configuration format, which makes it easier to maintain and expand as our project gets bigger and adds more tasks. First, we will install all the packages we need using npm. The --save dev command line switch will save the packages to the package.json file as dependencies of our project. We're going to use npm to install the test framework Jasmine, the Karma test runner, the Jasmine extension for Karma, the Firefox launcher for Karma, the Grunt task runner, and the Karma extension for Grunt. We'll need to create a configuration file for Karma so that it can run the Jasmine unit tests. We begin by opening up karma-unit.conf.js in the main project directory. We start by exporting a function that takes one parameter, the Karma configuration object, and we call set, and we're going to pass in new configuration parameters to Karma. First, we set the framework, which is Jasmine, and then we're going to set the browsers, in this case only one, in which the unit tests will be run. Next, we set the files that Karma will load up as part of running the unit tests. After Jasmine and Karma are set up, we can create an example unit test and run it. We create the unit test directory in spec, and after that's done, we can switch to our editor and then create the unit test in spec/unit/example.js. The example test will do nothing except check that the value true is equal to true. We set up the description of the test. example unit test, and then we set up our first test case. And as mentioned, we expect that the value true will be equal to true. This is a good way to ensure that the test harness is set up and working correctly. Now let's integrate this with Grunt Task Runner. First, we open up gruntfile.js in the main project directory. Begin by exporting a function that takes one parameter, grunt. We start by initializing the configuration and passing it a configuration object. We only have one task right now, karma. And there's a subtask within karma called unit. This will run our unit tests. The configuration file we use with karma is karma-unit.conf.js. After initializing the configuration for grunt, we have to load up tasks from grunt-karma. So the task we just created has to be loaded. Great. Now we can use grunt to run the unit tests. Later on in the videos, we can use grunt to run the end-to-end tests too. Let's take a look at how that looks right now. In our grunt file, we have karma task. And now we switch back to the command line and we write grunt karma:unit. This will run the karma task and the unit subtask. It starts up the browser Firefox. It runs the unit tests. Let me just move that out of the way, and we can see that it executed exactly one test, example.js. Now we have the infrastructure in place to write unit tests and to be able to run them. We can successfully practice test-driven development as we go along the project and make sure that our code is of a higher quality. In the next video, we'll be covering the project structure.
In the last video, we set up Karma Test Runner, Jasmine Test Framework, and Grunt Task Runner. Now we are going to set up the project structure for our pizza store application. In this video, we will be creating directories for project components, adding the AngularJS library and creating a base file, and creating one route to a controller and making an HTML template. First, we need to create the directory where our app will be stored. It is named app. Second, we create the directory for the scripts of our app, named app/scripts. In that directory, we also need to store the controllers, directives, filters, and services of our app. This includes app/scripts/controllers, app/scripts/directives, app/scripts/filters, and app/scripts/services. Finally, we create the directory for our HTML template views named app/views. Next, we create app/index.html, which is our base template. The title of our app is Pizza Store. In the body tag, we set the app module to load Pizza Store in the ng-app attribute. Then we set up the view of the app using the ng-view directive. We will be using the cdn.js hosted copy of AngularJS and the AngularJS route library by inserting the script tags into the header. Our app is named Pizza Store, and we need to include the scripts for the main controller and the app. Next, we set up the initial app script, app/script/app.js. In this file, we create the Pizza Store module with ng-route as a dependency of the module. Then we configure the default route to point to the main controller. After that, we can create the main controller. This controller will display a welcome message. We also need to create the template view that will be used with the controller. Let's open up apps/views/main.html and display the welcome message from the controller. Now let's open index.html in Firefox and see what happens. In the next video, you will see how to use Karma to unit test the controller and how to use Karma and Protractor to end-to-end test the controller route. In this video, we will be covering how to set up Karma with Protractor for end-to-end testing of an AngularJS web application. There are multiple levels to testing any application. Testing the smallest component isn't enough. We also have to test how it integrates with other components. But more than that, we have to test it within the same scenarios as the user will interact with it. Therefore, we need end-to-end testing to simulate user interactions. First, we have to install Protractor and WebDriver Manager. The WebDriver will be driving the web browser. Protractor is the library that allows us to manipulate the web browser to make it interact with our application in the same way that a user would. We use npm install save dev to install them. We also install the Angular dev server, which will run a local development server. This is required for Protractor and WebDriver to work correctly. We have to make sure WebDriver is updated using the WebDriver Manager update command. Then we start the WebDriver server using WebDriver-manager start. The web server will start on port 4444 and it will be what Protractor connects to. Now let's write a simple end-to-end test that makes sure we can navigate to the second page in our Pizza Store application. Next, we create the directory where the end-to-end test will be stored, the spec/end-to-end directory. Now we open the pageObjects.js file. We are going to define the homepage object with convenience methods and variables. The page heading property stores the welcome message element. The get method will tell the browser to go to the index.html page, which is where our main controller is used. The homepage object is a layer of abstraction that lets us focus on the actions that are taken on a page and testing that behavior, rather than worrying about whether we're using the correct CSS selector to find the DOM element we are checking. Page objects make end-to-end testing much simpler. Now we'll define the main controller end-to-end test. Open the main controller spec.js file. We are checking to make sure that after navigating to the home page, we see the heading has the text, "Welcome to the Pizza Store." Using the page object we defined for the home page in pageObjects.js makes it very easy to test what's happening. Next, we have to configure Protractor, so we open the protractor.conf.js file. We set the Selenium address property to the localhost at port 4444, which is the default port. The specs are the tests to run, and they are stored in spec/end-to-end. The capabilities sets the browser to use and what it can do. In our case, we're testing using Firefox. The base URL sets where the server is that will run the tests. If we're using a local development server that serves the AngularJS app at port 8080/8080, now run the local development server. Then run Protractor. It will connect to the Selenium WebDriver server, and then use the local development server and run the tests. We see that the test passes on the command line. Now we have the infrastructure for both unit testing and end-to-end testing. We have successfully set up Karma to run unit tests and end-to-end tests. We have Protractor working so that it can run end-to-end tests. End-to-end testing is very important for full test coverage. In the next section, we'll add a few controllers and directives and test their interaction. Hello and welcome to the second section of this course. In the previous section, we set up Grunt, Karma, and Protractor for unit testing and end-to-end testing. In this section, we're going to be testing controllers. In this video, we're creating a controller for selecting a pizza type and then writing a unit test. When we're writing an AngularJS app, we always start with a controller that exists within a module. Modules group together controllers, services, and directives. Controllers control how the user interacts with the app and ties services and directives together. In our case, we start with a simple controller that has no dependencies on any services. We start by writing the unit test for our controller in spec/unit/selectPizzaControllerSpec.js. Before we write any test, we have to load the Pizza Store module and inject the select pizza controller. We use the scope variable to keep track of the controller's scope. This is how we'll call and inspect the controller scope variables. Now to write our tests. What we want to test for is whether we can place an order or not. In our first test, we set the pizza type to a blank string and then call placeOrder. We expect that no order will be in progress. In our next test, we set the pizza type to the first choice that a user can select. Then we call placeOrder and expect that there will be an order in progress. Now we open a new file where we will place our controller and write code that passes the unit tests that we have just created. We define the pizza choices that are available: Canadian, pepperoni, and vegetarian. We also define the pizza type that is currently selected. At first, this is blank, which means there's no pizza selected. Open the HTML template for the controller, and let's add multiple choices for the type of pizza that customers can choose. We're using the ng options directive to populate the choices of pizza type that can be selected. This simplifies our HTML template, and it's also easier to test. Open the app.js file and let's change the main route to point to our new controller and template. Instead of using main controller and views/main.html, we will be using select pizza controller and views/selectpizza.html. When we hit that particular URL, the router will load the template and controller. This is something we will test later on in video 3 of this section with an end-to-end test. For now, we are focusing on unit testing the controller. We also need to load the controller JavaScript file. Let's open index.html and add it to the head element. Unit tests to see that they fail. Let's update the controller to implement the placeOrder method so that we can start passing the unit test. Since the controller has no dependencies, we will be pretending that it makes a call to a service that places an order. We check if a pizza type is selected and then set the scope variable order in progress to true. Next, we add the unit test to our Karma configuration file so that we can run it. However, before the unit test is loaded, we also need to load the AngularJS libraries. To be able to run unit tests, we absolutely need to load the ngmux library. Now we run the unit test, and it checks to make sure that the drop-down selection is working and that our controller can see the changes in its scope. That's how we write a unit test for a controller that has no dependencies. Awesome! In the next video, we will discuss how to add a service to the controller and how to test this controller using a mock service. In the previous video, we created the Select Pizza controller and set up the initial user interface of our app that lets the user select a pizza and then click Place Order. In this video, we're going to hook up the Place Order button to a service. In real-world AngularJS apps, you will typically write controllers that depend on one or more services. In order to test the controller, we also have to test the service, or at least we have to make sure the controller is calling the right functions in the service. We use mocks to be able to test controllers that depend on services. Open the file app script services order service.js, and let's define our service. This service is going to be used for placing orders using an AJAX call to a REST API. To keep things simple, we will not be implementing the AJAX call right now, but we will need the queue module for creating promises. Our factory will have a dependency on queue, the promise module. AngularJS will inject this dependency when we run the tests and when the web app is run in the browser. Next, we write the method for placing an order. It will return a promise provided by the queue module that returns a successful result right away. Typically, a promise will not resolve right away. This makes them great for handling asynchronous tasks. If we wanted to, we could make the promise resolve within a few seconds or a few minutes to simulate a real API call. In this case, we want to resolve the promise right away because this way our tests will run faster. Open the Select Pizza controller and add the service as a dependency. Now we write the method for the controller to place an order, but only after a pizza type has been selected. Open index.html and add the service to the load file list. This makes sure it works on the front end for the user. Open karma-unit.conf.js and add the service to the files list. Next, we open the Select Pizza controller spec, unit test, and create the mock service. We use the createSpy_obj method provided by the Jasmine testing library to create an object that can be spied on. Spying on an object lets us monitor when it's been called or modified. Our mock order service is going to return a promise object that does nothing. The mock order service only monitors when the place order method has been called and has no side effects and does not affect the rest of the system in any way. This is the ideal design for mocks. We have to update the controller to inject our mock order service. Then we update our unit tests for placing an order. We want to ensure that the order service place order method is being called by the controller's place order method. Testing for this is important because if the service method is not called, the user's order will never go through. We replace the expectation of order in progress to be false or true with the expectation that the place order method of the order service has been called. Now we run our unit tests. We have a mock for the service in our controller test, and when we see it running, we see that indeed the controller does call the place order method. That's as far as we can test this, and in a real-world environment, we would be running unit tests like this with and without the mock service. With mocks, tests run faster and you have a smaller number of dependencies to worry about. Without mocks, you can end-to-end test this with the real service. In this video, we learned how to mock out a service, and this is something that will come up frequently in more complex projects. In the next video, we cover end-to-end testing two controllers with Protractor and writing end-to-end tests. Join me there. In the previous video, we covered testing a controller that has a dependency on a service. In this video, we're going to talk about how to create an end-to-end test that replicates what a user would do. When we're writing applications that require lots of user interaction, we absolutely have to test things in such a way that emulates what the user will do. Unit tests are needed to test business logic and to test integrations, but we need end-to-end tests to make sure that the user experience is great. Open the file order status controller and let's write a controller that displays our order status. Next, we will write the template for the order status controller. Now let's add the order status controller to the routes of our app. Finally, we have to add the order status controller file to the index.html file so that it can be loaded in the browser. What we're testing is the process of placing an order. The user will navigate to the homepage of the pizza store, so we use browser.get to navigate to the home page. Then we test to make sure no redirects have happened by getting the URL and comparing it to the slash, using the browser.getLocationApps URL method. Next, the user will select a pizza type and then click Place Order. We select the pizza type options using element.all by tag name option. Then we click on the option. Then we select the Place Order button using the button text selector. We trigger a click on the button. Finally, we are going to check to make sure that the location of the browser has changed to the order status page. We check to make sure that the option was selected. Now we run the test and we see that it fails. We have to update the select pizza controller so that we can navigate to the order status page. Open the file select pizza controller and let's update the place order scope method to continue to the order status page. We first add the location service as a dependency to our controller. Next, we update the place order function, and when the order is placed successfully in the order service, we use the location service to change the URL to go to the order status URL. Run the protractor test again and we'll see that the test passes. Great job! In this section, we learned how to write unit tests and end-to-end tests for controllers that have dependencies on services. In the next section, we will be creating and testing directives. In this section, we're going to be covering how to create and test a directive using unit tests and how a directive becomes part of end-to-end testing. In this first video, we're going to be creating an accordion directive. An accordion user interface displays panels that can be switched between by clicking on a panel title. Before we start writing our accordion directive, we need to find out how we want to use it. We open the select pizza template and we pretend that the accordion directive already exists. We create a panel with the title Special Deal that contains some text. The H2 element contains the accordion panel title. The div contains the body of the accordion panel. We create a second panel titled 25% off vegetarian pizza. The title is in the h2 element, and the body of this panel is in the div. Now to start writing our accordion directive. First, we create the directory where directives will be stored. Then we open accordion-directive.js and start writing our directive. First, we make the directive part of the pizza store module. Second, we name it accordion. Then we start setting the options for the directive. We restrict it to E, which means we can only use the directive as an HTML element. We set transclude to true because we want the accordion directive to display whatever is contained within it in its template. The scope is set to an empty object because we don't want to inherit the directive's parent's scope. This is also known as an isolate scope. When a directive has an isolate scope, it can be used multiple times on a page. For example, we could have more than one accordion directive used on the page. Moving on. The template of the directive will define inline because it's basic. We want the accordion element to display whatever HTML is inside of it. Now we get to the good part, the link function, where we code what will happen when the accordion element is created. We will find all div elements and set their CSS display attribute to none. This means all panels will be closed. Then we will bind the click event to all panel headings. When a user clicks on a heading, we will close all the panels, and then we will find the panel div element which is next to the heading in the HTML, and then we will set the CSS display attribute to block. This will display the panel div element right beside the heading element. Add the directive JavaScript file to the index.html file. Now that we've done that, we can run the Angular dev server and load up the site in a browser and see the results. When we click on a heading of a panel, the panel div shows up. Great, this is what we wanted our directive to do. We aren't going to write unit tests for the accordion directive in this video, but we'll add the accordion directive JavaScript file to the Karma configuration file. In this video, we went over how to create a directive. We did this without the benefit of testing. At first, it's pretty easy to test a directive manually in the browser for the happy case where everything works. But it's also pretty easy to miss things and not fully test the directive. In the next video, we're going to write some unit tests for the accordion directive and fix any missing functionality. In the previous video, we created an accordion directive. In this video, we will be writing unit tests to prove that the accordion directive works properly. Unit testing an interface component can be difficult, but with Angular and Jasmine, we're able to do so easily. AngularJS is specifically designed to make all components, including user interface components, testable. It does this through the use of dependency injection, which makes it possible to stub or mock out whole modules that your code depends on. The separation of concerns between the controllers and directives in AngularJS is the reason we can test the directive properly and in isolation. Let's begin by creating a new test specification for the accordion. Open the file accordion-directive-spec.js in the spec/unit directory, and let's begin with defining the HTML that we'll use and display our accordion directive. It will contain 2 panels, which is enough for us to test. Then we declare the scope variable, which will store a reference to the root scope. This is needed when we're compiling the HTML to display the accordion. After that, we declare the element variable. It will be storing the compiled version of the HTML. To make things easier when testing, we define 2 convenience functions, getPanels and isHidden. GetPanels will return all panels in the accordion, which are just divs. isHidden will return true if the given panel is hidden. That is, when the CSS display attribute is equal to none. When the panel is shown, the display attribute will be equal to block, which means that isHidden will return false. In our tests, we will use getPanels and isHidden to keep the tests shorter. Creating small helper functions like these is much the same thing you would do for production code. With Jasmine, you can integrate these small helper functions as custom matchers. The isHidden function would be a prime candidate to be a custom Jasmine matcher. A custom matcher works like the toBe or toEqual functions in Jasmine. Treating your tests as if they were production code is a good pattern and leads to high-quality tests and high-quality code. Before each test, we will need to load the pizza store module. Also, before each test, we need to compile the HTML and then run the linking function, linking fn, and pass the scope variable to it. We store the compiled and linked HTML in the element variable. Now we write our first test for the accordion. When the accordion is created, it will start with all panels closed. We get all the panels, and then loop through them, and expect that they are hidden. Remember that isHidden will return true if the panel's CSS display attribute is set to none. In the second test, we want to make sure that only one panel will open at a time when we click on the panel's title. First, we check to make sure that the first panel is hidden before clicking. Then we click on the first panel's title. After clicking, we expect the first panel to be shown and the second panel to be hidden. After clicking the second panel's title, we expect the first panel to be hidden and the second panel to be shown. Now that we've set up the tests for the accordion, let's run them using Grunt Karma Unit. Let's open the accordion directive and make sure that the second panel is hidden after the first panel's title is clicked. Currently, when we click on the panel's title, we show the panel. What we need to do before that is hide all panels. Then we open the one panel that needs to be shown. Now run the unit tests again and we see that the tests pass. Our first attempt at writing the accordion directive was pretty good, but when we wrote the unit tests for it, we found that it was missing a key requirement. This is why unit tests are really powerful, especially for user interface components like directives. In the past, with only jQuery, it was incredibly difficult to unit test individual parts of the user interface. AngularJS makes this much simpler and encourages it with the separation of code into controllers, directives, and services. The unit test for the accordion directive wasn't complicated and it was easy to understand. In the next video, we will add the directive to the end-to-end test from section 2. In the previous videos of this section, we created an accordion directive and then wrote some unit tests for it. In this video, we'll be adding interaction with the accordion directive to the end-to-end test for placing an order. Sometimes the directives you use in your templates and views will have an impact on the end-to-end user experience. In the previous video, we added the accordion directive to the select pizza template HTML. We opened the end-to-end test for placing an order, and let's click on the panel headings a few times before we place an order. We select all panel headings by tag name. Then we click the second panel heading, and the browser sleeps for 1 second. This makes it easy to see what's happening, as Protractor and Selenium run through the test in the browser. Then we click on the first panel heading, and again the browser sleeps for 1 second. Then we click on the second panel heading and wait another second. Don't forget that we first run the web server for the site. And then we run the Selenium server. Now we run the Protractor end-to-end tests. As we can see, nothing has changed and the tests are still passing. This is a good thing. With the calls to browser.sleep, we can clearly see that clicking on the panel headings is opening and closing them. In this video, we covered how to interact with a directive within an end-to-end test. In this section, we covered how to create and test a directive. Creating custom directives is a core part of AngularJS development, and it's important to know how to fully test them. In the next section, we will cover testing controllers that rely on resource-based REST API services. In this section, we are going to be creating a service that uses the Angular resource module. This allows us to easily use REST API web services with our controllers and directives. In this video, we are creating and testing the resource service using mocks and spies. A web app needs to interface with our server backend, which is a REST API, or needs to use some other REST API. To do this, we can use the resource service, which is included with AngularJS when you install it. Since we are practicing test-driven development, we start by writing a unit test for the service. Open the file spec/unit/order-service-spec, and let's begin. Our service is going to be used for placing orders and getting the status of an order. First, we want to load the pizza store module. Then we have some setup to do before any tests are run. Our service requires that we mock out the HTTP backend, which is used by the resource module. We also need to inject a reference to the root scope and to the order service itself. Then we mock out the HTTP backend. The first API call we want to define is for placing an order. Using the when method of HTTP backend, we are saying that when the mock backend receives a post request to the /API/order/place URL, it will return a certain response. The respond method defines what the response will be. In this case, we want an HTTP response that has a 200 status code, meaning it's okay, and the response is a JSON object that has the ID of the order and its status, which is in progress. Basically, after we place an order, we expect a response that says the order is in progress. Let's mock out the second REST API call. We want to get the status of an order, and it's reasonable to expect that the URL looks like /API/order/1/status. The 1 is where the ID of the order would be. The response when resource hits that URL with a get method is a 200 status code and a JSON object that has a status of not ordered. Now let's start defining the unit tests. The first one is for placing an order. Important to note here is that we are dealing with asynchronous functions now. With resource and HTTP requests, you will not know how long the request will take. This means your test will also need to be asynchronous. The done parameter in our test can be called at any time to signal to the Jasmine testing framework that the test is indeed done. The HTTP backend provides the methods expect get, and expect post to ensure that there is a request made through resource to the HTTP backend. We expect that there will be a post method made after we call order-service.placeOrder. When we call placeOrder, we expect that when the request is finished, we will be receiving the status of the order to be in progress. After that, the test is complete. After we define our test conditions, we need to call HTTP backend flush. In the mock HTTP backend, this will run through all the HTTP requests that have been created, such as the one we created when we called the placeOrder method. After flushing the HTTP backend, we have to call root_scope.apply to ensure that the scope is processed and that promises are executed. Now we're going to test getting the status of an order. We start by defining the unit test where we don't want an HTTP request to be sent. This happens when we haven't placed an order yet. To test this doesn't involve the HTTP backend at all. We simply call the getOrderStatus method in the order service and pass in a function to the promise returned by the method. We expect that the status will be null. Remember that we are writing an asynchronous test, so we will call the done function after this. After defining the test, we call root_scope.apply to process the getOrderStatus promise. In our second test, we want to make sure that the order status is in progress after we place an order. First, we want to make sure the getStatus handler returns the right response. it should return a response with a JSON object that has a status of in progress. We are making two HTTP requests. The first POST request is made to place an order, and then the GET request is made to get the status of that order. We write the expectations for these requests. Now we call placeOrder and then getOrderStatus. Then we expect the status to be in progress. Again, we repeat the steps of flushing the HTTP backend and running apply on the root scope. With that, we're done defining the unit test for order service and can begin implementing it. Open the order service and you can see that it doesn't do anything useful since its implementation is mocked out. We update the dependencies to include resource, which is how we're going to hit the REST API. We have to define an order resource. It will hit the API/order/ID/controller URL. It will use the ID and controller parameters to replace those in the URL. It has two additional methods. One called place, which is a POST request, and its controller is place. The other is called getStatus, and it is a GET request, and the controller is set to status. Now we run the unit tests and we see all tests are failing. Let's fix that. Open order service and let's implement the placeOrder method. We are going to call the place method on the order resource. We pass the pizza type on to the place request and wait for a response. Run the unit tests again and we can see that the place order test passes. Let's get to work on the getOrderStatus implementation so that the tests for it pass as well. Open orderService.js again and let's continue after the place order implementation. GetOrderStatus will need to return a promise to match what we have in the unit tests. When an order is placed, we call getStatus on the order resource, which will make the REST API call to the server. Right now, we are using sample data, so we pass in 1 as the order ID. When that's successful, we resolve the promise with the status of the order. If an order has not been placed, we just return null as the status. Now try running the unit tests. We see that all tests have passed. That's all for video 4.1. We did test-driven development and wrote unit tests first and coded to them. We used the resource module from AngularJS, and we developed a mock for use in our unit tests. In the next video, we will create a REST API server to serve fake data so that we don't have to use mocks. Thanks for watching. Welcome to video 4.2, creating a REST API Node.js server with fake data. In the previous video, we talked about how to create and test the service that uses the ng resource module, and how to use mocks to test it. In this video, we'll be talking about how to remove the need for mocks by creating a REST API server that serves fake data using Node.js. To make sure that integration between your front-end AngularJS app and the back-end REST API services you use goes smoothly, we need to make a server that has fake data. This will make it possible for us to use Protractor for running end-to-end tests. When we write unit tests, we use mocks to keep the tests self-contained. In the unit tests, we don't make any requests to any REST API server. When we write end-to-end tests, we want to make sure that everything is functioning end-to-end. We are writing a server that serves fake data because we don't have a real REST API server backend. In the real world, you will typically have a backend REST API server running, which you can use to test, though it's advisable to also have a fake data server. A fake data server makes testing end-to-end easier and faster. The server we're writing is going to be written in JavaScript using Node.js, and we're going to use the Express web app library. Express will let us get a REST API server up and running quickly. We begin by installing Express so that we can use it in our code. We type in npm install and save it to the package.json file. Then we open the file api-server.js in the main project folder. It will be kept separate from the AngularJS app code. We begin by importing the Express library and creating the web server. We call it app. The most important step is that we need to enable CORS for all requests when testing. CORS stands for Cross-Origin Resource Sharing, and some browsers block requests based on the origin, and some servers also block some requests based on the origin. We want to enable CORS so that we aren't blocking the REST API calls from the service when testing. Now we write the first API method. Recall that in the last video, we already have a way to place an order with the AngularJS code that we wrote. Whenever an HTTP request hits the URL /api/order/place and it uses the post method, it will respond with a 200 OK status and send the data of the new order back. We are serving fake data to make testing easier, so we just send back an order with an ID of 1 and a status of in progress. This next API method is more complicated. An order goes through multiple steps. First, there is no order placed. The second step is that the order is placed, so it is now in progress. The third and final step is that the order is complete. Finally, we need to start the API server. We do this by calling the listen function on the app. We start the server on port 9999 and print out a message to say that it's been started. Now run the API server. As it runs, we'll be able to see each API request made. And that's it for this video. We have a fake API server and can properly test manually with the API or write end-to-end tests. In the next video, we will be using the server we just created to write a directive that we can test with an end-to-end test. Welcome to video 4.3, displaying information with a directive from a service. In the previous two videos, we implemented an order service and created a fake API server for testing. In this video, we will be creating a directive that uses the service and testing it with unit tests and end-to-end tests. We want to be able to create directives that rely on services and be able to test them with unit tests and end-to-end tests so that we can be sure that it works correctly. In our pizza store web app, we're going to display the status of the order as it's happening. Since we're practicing test-driven development, we're going to begin by writing a unit test for this directive. Open the file order status directive spec in the spec/unit directory, and let's start writing the unit test. First, we need to mock out the service. We need to store a reference to the order service and then create a fake implementation of the getOrderStatus method. On the first call to the fake method, we will return a promise with the status message not ordered. On the second call to the fake method, the status message will be in progress. On the third, fourth, and any other calls to the fake method, the status message will be complete. Then we assign the fake method using spy on and call fake. We spy on the order service method getOrderStatus, and whenever it's called, we will be calling the fake method. The point of this is to make sure our directive acts appropriately whenever the behavior of the underlying service method changes. This is what we will be testing for. Next, we have to compile the HTML template that will use our order status directive. We are going to follow the same pattern as before, creating a new scope, compiling the HTML template containing the directive, and running the AngularJS digest method on the scope. Now we finally get to the unit test itself. We expect that the order status element will display a list of statuses. Whenever the order status is updated, we add a new item to the list which shows the new status. Before we get into the next bit of code, we have to do a quick review of how directives and controllers are notified of changes. AngularJS provides two functions for sending notifications: emit and broadcast. The emit function sends information up the scope chain. The broadcast function sends information down the scope chain. To listen for this information, we use the on function. So first, we expect that there is only one item in the list, the not ordered status. Then we want to broadcast a message to the scope that the order status directive will be listening for. When the directive receives the check order status message, it will contact the REST API service and then update the list of statuses. We expect that there will now be two statuses in the list, not ordered and in progress. When we broadcast check order status one more time, we expect that a third status will be added to the status list. The third status is complete. When we run our unit tests, the test for this will fail. Now we implement the getOrderStatus directive to pass the unit tests. Open the file orderStatus directive in app/script/directives directory, and let's begin. The directive relies on the order service REST API, and we are restricting it to an element tag. It will have a new scope, and the template is list element. The link function is where we define a check status function, which we'll call the getOrderStatus of the order service. When the status is returned, we add the status as a list item to the status list. After defining the check status function, we call it to make sure that we get the right status of the order. Next, we listen for the check order status message that will be broadcast whenever we need to check for the order status. Using the broadcast means that we can trigger a check for the pizza order status every 30 seconds or every 3 to 5 minutes, and the directive will be updated. Now run the unit tests, and we see that they all pass. Next, we rate the end-to-end test. We're going to use the existing place an order spec and just add a few lines at the bottom to make sure the order status is showing up. We have to inject the root scope into the function, and then we broadcast the check order status message. We wait a second and then check to see how many elements have appeared. Then we wait another second and again check to see the status of the order. This is a good quick test because it makes sure the order status directive is appearing on the page, that it's communicating with the REST API server, and that it updates. Recall that in Section 2, Video 3, we created a view and controller to display the order status. We need to update the order status controller to match the new spec. First, let's update the order status view. We replace the HTML for displaying the order status with the new order status directive. Now let's update the dependencies of the order status controller to include the interval service. The interval service is a testable way of using setInterval. Next, we set up a check order status function that is triggered every second. It will broadcast the check order status message that the order status directive will listen for. Finally, we need to make sure that we stop checking for the order status when the controller is destroyed. Typically, the controller will be destroyed when you navigate to another page. For example, after checking the status of our pizza order, we may want to look up the menu or look at something else on the website. The order status directive should not be updated any longer since we won't be on that page anymore. And that's how we create a directive that depends on a service and fully test it. It didn't take too much work to be able to unit test and end-to-end test it. In the next video, we'll do the same thing for a controller that depends on the order service. Welcome to the final video of the course, displaying information with a controller. In the previous video, we created a directive that uses the order service API to display the status of a pizza order. In this video, we will be updating our controller to rely on the order service API. We want to be able to create a controller that relies on a service and be able to rapidly develop unit tests end-to-end tests, and update the fake API server. In our pizza store web app, we're going to display a coupon after the order is delivered. We begin by defining the unit test for this and the end-to-end test. Let's open the unit test for the order service and write the unit test for how we expect the coupon display to work. We set up the expectation that there will be an HTTP GET request made through the HTTP backend, which is used by the resource service. When we make a request for a coupon, we expect that the result will be some text and a coupon code that the customer can print out and use on their next order. When the request is successful, we expect that the text and coupon code keys will not be empty in the API response. Now we write some code to pass this unit test. Open order service and let's implement the getCoupon method. First, we need to update the order resource and add a new API endpoint. We call it getCoupon, and the HTTP method used is a get method, and the controller parameter in the URL will be set to coupon. Now we have to write the end-to-end test for protractor. Open place an order spec in spec/end-to-end, and let's go to the bottom of the file. After the user orders the pizza, the status of the order is displayed and changes until the pizza is done. At that point, we want to make sure the coupon is displayed. So by the time the user is waiting for their pizza, they should see the coupon. First, we get the coupon element. It will have its ID as coupon. Then we make sure that there's some text in there. In the end-to-end test, we're just checking for any sort of coupon text to show up. In the unit test for the coupon, we already are checking to make sure the correct text shows up. Next, we open the order status controller and update the code to match the new functionality specified by our end-to-end test. After we set the order status in the scope, we set the coupon in the scope to null. Then we call getCoupon from the order service. When the call to the REST API is complete, we store the coupon in the scope. Now we update the order status view. We add the HTML for displaying the coupon and display the text of the coupon as a heading, with brief instructions on how to use the coupon code. And that's how we write a controller that depends on a service and test it. When you have a strong foundation for writing unit tests and end-to-end tests, it's very easy to add new tests and features. The amount of code we wrote for displaying coupons was very small, and the test code was small too.